Very good morning, good afternoon, and good evening to all. I am Dr. Vanna. I did my PhD from Department of Mathematics, Punjabi University, Patiala, under the supervision of Professor Satyaveer Singh. Presently, I'm working as assistant professor in Khalsa College, Zirakpur. I would like to express the most sincere gratitude for the presence of all candidates in third technical session of this international webinar on intelligent optimization techniques and their real-life applications. The great British statesman Winston used to say, "I'm always ready to learn, although I don't know, always like being taught." So now, it gives me immense pleasure to welcome our source person, Professor I.A. OSINUGA, sir. Professor I.A. OSINUGA is Professor of Applied Mathematics and former acting head of Department of Mathematics, Federal University of Agriculture, State is Ogun, Nigeria. His research interest is in non-linear optimization, applied operation search, and computational mathematics. He has published about 50 plus articles in national and international journals.
Hello. Madam, please unmute. Hello.
He is also involved in book project on implementation of open access solutions since 2009. He is also a member of many societies such as Nigerian Mathematical Society, Society for Industrial and Applied Mathematics, London Mathematical Society, and America Mathematical Society, etc. So once again, I warmly welcome to Professor I.A. OSINUGA and requesting to you, sir, to dignify and magnify us with your talk. Over to you, sir.
Thank you very much. Morning, everybody. Good afternoon. I hope you can hear me. Can I go ahead?
Yes, sir.
Okay, thank you very much. I want to appreciate the organizer, from the head of the department to the dean. On behalf of the management, I want to also thank the Vice Chancellor for this great opportunity. I want to sincerely apologize for what happened this morning. It wasn't intentional, but I'm very grateful that we still have the opportunity. I have the opportunity to still stage a comeback. I'm so happy to be with you. As you can see, what I have to share this morning is intelligent optimization in the era of big data. The era of big data. Well, it's just one of the talk to be delivered or being delivered now at professional webinar on intelligent optimization technique and their real-life application organized by Professor of Mathematics, University Patiala, and so on. Next slide. Next slide. Next slide. Next slide, please. Next slide. Thank you. Slide, please. Okay, the outline of my talk is as follows. I'll be discussing on introduction, what is actually optimization. Then you also know, are you aware there is optimization in nature? I'm going to discuss about the hexagonal geometry of the B cells. Likewise, planetary science. The background of the talk is going to dwell more on what are we optimizing? Life, money, other resources. How are we able to do that to process improvement, to also eliminate waste and intuition? Then mathematical optimization and application in pure and applied sciences, engineering, management and social sciences, communication and information sciences, and the rest. And under methodology, we shall be looking at several optimality methods to handle this, what we are talking about. That is, how do you optimize? And a way to handle big data, the construction of a mathematical model to describe each problem. Then how do you now find solution using intelligent optimization? And the last is going to dwell more on the real-life application. Next slide. That is going to be an abstract, and what I intend to discuss is just to invoke discussion. I want to dwell more on the importance of the intelligent optimization technique as against the derivative-based optimization method to enhance productivity, durability, efficiency in this era of big data. And the meta-heuristic, much has been said about meta-heuristic technique, but I will also still discuss more among those that I will make mention of the genetic algorithm, simulation, annealing, particle swarm optimization algorithm. Then furthermore, it is shown that the techniques are necessary in finding solution to the ever-evolving complex optimization problem in pure and applied sciences, engineering, communication, and information sciences. Well, to start with the introduction, this paper complements the work of other authors on intelligent optimization technique that are found very, very crucial in the present day, the big data era. And I'm sure the brief analysis of real-life application may invoke further development, further study this area. Technically, we are talking about the act of making the best or the most effective use of a situation or resource. And we can as well liken it to an exercise of maximizing or minimizing an outcome for a definite purpose. The situation we are talking about in search for the best alternative is what we refer to as what? Optimization problem. And the best alternative we are looking for is actually the solution. Next slide. Now, like I've said, the optimization is exhibited in our day-to-day activities. There are several occurrences in nature that are involved. You minimizing at one point or the other or maximizing certain quantity. As human, the application is available with us. First, in the way we interact, in the way we work. In fact, a very close example is the way we queue at the ATM facility, or decision we will make to take care of the welfare of our loved one. And the first examples of the organization in nature, ever busy swarm of bees filled honeycomb, is typical of organization in nature. I want the participants, distinguished participants, distinguished professor in our midst to know that the hexagonal shape of the honeybee cell is a geometry that demonstrates magnificent of optimization. In fact, it has taken the mathematician Thomas Hell to come up with what we refer to as a honeycomb conjecture. It gave it to us in 1999, and it concluded that, well, the more compact the shape of the honeycomb cell, the less energy and wax a bee would use to build it. Next slide, please. So that we can look at, if you look at this diagram by Stacy George, 2017, if you look at this diagram from distance, you are going to think the shape of those honeybee comb is circle. It is never circle. So a very simple advantage of this hexagonal shape is exactly what we intend to illustrate. Now, if you take any shape at all, take circle. As you are seated, you can just, a very simple exercise, just take circle and try to match them. You are going to see the nature in this hexagonal shape. Try to use triangle and any other shape of your choice. You discover that this particular shape, hexagonal, which is actually a very good demonstration of organization in nature, is telling us, is showing us how bees are able to conserve space. They are able to, at that space now, in the recess of it, they are able to conserve energy to survive, to reproduce, to produce honey and wax. So the more compact this shape is, the safer for them to take care of the wax and to also conserve the energy that can be expended on other things in life. So that is one very good demonstration of organization in nature. Next slide, please. Now, another very good example is planetary science, which also affirms that one of the 4 terrestrial planets, Mercury, Venus, Earth, and Mars, it is the only one that is habitable for life to exist remain Earth. And why? God has chosen that the creator of the entire universe applied organization there, because that is the only terrestrial planet where you can have, God has provided abundant resources, which include water, and it's also free from harmful gases and solids. And we are also able to have, God provided a reasonable temperature that is habitable for living things. So that is that. So now, among the background information here is what actually are we optimizing? What are those things that we have? Those things that we intend to optimize are varied, but can just be summed up as our resources. According to Wikipedia, the resources are all possessions which assist us to satisfy our necessity. What are those resources? Talk about life, talk about money, we talk about other resources you can think of. And in all these resources we are talking about, you are going to make use of them. You are going to use them in improving the process of optimization. Making effort to cut down waste is one way by which you can attend to the process or improve the process of optimization. And likewise, your intuition. And that is the powerful force that helps the mind to make better decisions. Even the government also, they are interested. The world body is also interested in optimizing, according to the United Nations Agenda 2021. Yeah, they put up how we can manage our resources. Now, this mathematical optimization is a field of study in applied mathematics arena, and it offers so many applications. And the field offers techniques and strategies that are built on sound theoretical foundation for resource management. All those resources we have listed, be it renewable, be it non-renewable, they are all resources that are needed to be taken good care of. We need to optimize, we need to try as much as possible to reduce waste and so on and so forth. Now, here are the applications of mathematical optimization. Pure and applied sciences can talk about radiation therapy, optimal experimental design, tumor analysis, data analysis and modeling. In engineering, we have a lot: signal processing, production planning, electronic cycle design, communication and networks. We also have in communication and information sciences, artificial intelligence neural network, and also in management and social sciences. You have also those listed, which include supply chain management, security management, scheduling, and decision science. Next slide. Now, what is the process? The most crucial step in optimization process is the construction of an appropriate mathematical model this time around, because there's a lot of models you can think of. And the model is being described as an abstraction of the real life situation. Yeah, we have seen a toy car. It's a physical model. This model we are talking about, mathematical one, when constructed properly, our application function, variables, restrictions of the given problem, and to be able to apply effectively, there is a procedure, especially what we call mathematical modeling cycle or procedure. And those procedure is necessary. Yeah, as you can see, the ACT Act 2010 is giving us a sample here that this procedure can as well be made use of. Now you need to specify the problem. Yeah, one of which is just what we explained this morning, where my speaker is not working. I will try as much as possible to be more proactive in future so that I don't keep our distinguished guests, professors, practitioners waiting. So we need to specify the problem. After that, we can set up a metaphor. And what I meant by metaphor is that this is where you need to specify your variables, your equations, your inequalities first. A very good example, when we are discussing linear programming, we first of all identify additional variables. It's in a manufacturing industry. How many products are we making? We denote each product, say X1, S2, S3. Then we now formulate. That's exactly where we need to bring up the proportion of the combination. So you have to formulate mathematically. After that, you need to solve mathematical problem. In solving, several methods can come in. Yes. For example, now a linear programming problem, we talk about graphical method, we talk about simplest method, we talk about any other method you have used earlier on. So to come up with what the values of your decision variable will be, and as well as your objective function value. After that, you have to interpret. Is it actually in line? Yeah, we have to interpret the solution. Is it expected one? Hope it's not too far. Hope it's not too far from the expected solution. Then we can as well compare with reality. At times, we need to stage a comeback. To go back to set up our metaphor here, you can see the metaphor here. You have to come back here at times. If you discover that in comparing here with reality, is not given the supposed result, you have to come back. At times, your staging a comeback may take you back to formulation here as well. So you can come back here to redo. And after that, solve again, you interpret the solution. But if everything is assumed okay, then you can now implement. How best we are able to use that, the model, to explain, to predict, to decide, and to design. So many results come up here. So that is that. So that is the procedure. Next slide, please. Okay, now we want to have a look. Well, I deliberately want to bring up the little mathematical symbols that we make use of, but devoid of too many technicalities. So we minimize as a standard problem f of s subject to this my set omega here. Then my function is differentiable, continuous, and that is what is called the cost function of the function. What am I trying to look for? I'm looking for my addition variable x, and their n vector of independent variable, and they must be in this my bigger set array. The variable addition variable here, my set here is what we call the constraint set. That is my constraint set, and that is where I'm going to bring up my solution. Generally, that is that. But my constraint set, I'm going to dwell more on it later on. Next slide, please. Okay, the problem defined above is actually a decision problem. It involves how you can find the best among all alternatives. All possible vectors in your omega, in that bigger set, so to say. The best vector S is the one that minimizes or that gives the smallest value of your function, and which we usually refer to as a minimizer. So the problem has been given in a general form of a constrained optimization problem. If it is unconstrained, if I'm referring to the whole search space, omega equal to Rn here, it's unconstrained. But the constraint set are usually given this way. And that is telling you that, okay, in the constraint set, I'm specifying here my equations and the inequality, where my H here is my equality constraint equation, and my inequality constraint equation, which can be less than equal to or greater than or equal to. Next slide. Now, the types of solution that is one of the essence, because most of the technique or method get trapped in the local minima. What do we call the local minimizer? Is that same point. I will call it X star here, where I define a neighborhood, and then I can see my S star in omega slash my S star when this my condition is met, and that is my neighborhood. Okay, but for the global minimizer, the whole entire space. So what is the least of the value I'm going to get? And at times we do have strict global minimizer or strict local minimizer, as we depict now in figure 3, and that is below for just one-dimensional problem. One-dimensional problem. Next slide. So I have examples there of my minimizer x1, which I call a strict global minimizer here, and I have my x2, a strict global, local minimizer, and I have my x3 here, which is local minimizer too, but not strict, according to the Shong and Sack 1996. Next slide. Now, the methodology we have been talking about. How do we now solve optimization problems? Now, conventional methods have been in existence in science and engineering application. They have been grouped into two. We have what we call the direct search methods, and we have what we call the gradient search method. Where in the direct search method, we only require objective function value. But in the gradient search method, we required information, gradient information. Either we can as well get it, our solution exactly, or we can as well get it numerically. So, but there are reported suitable for well-behaved unimodal simple objective function. Yeah, one of my last speaker yesterday demonstrated to us one of the function which we call test function, Rosenbrock function. If we have two variables unimodal, but when the Rosenbrock function, when you come about with too many variables, you are not find it easy with the direct search or gradient search. Any attempt to use this on multimodal problem, or problem where gradient information is not available, we have most of the problem. Methods, backsliding, degrading, failing. So, and that's exactly why we are moving forward. Yeah, we have to still look for a very concrete solution, concrete method of algorithm or strategies. And this suggests that in order to solve complex, multimodal, discrete, or discontinuous problem. Yeah, there are different types of problems, as you can see, and each and every, that's the reason why according to one of my distinguished speakers yesterday, Professor Kusum Deep said, we don't usually have a general method because each method are meant to handle specific. Discrete problems are meant to be handled with a particular strategy, likewise, discontinuous, and so on. And now, despite the inability of this method, I'm talking about the earlier method, the gradient-based, to handle a wide variety of problems with ease. The study still forms the basis for developing most of the other techniques we are going to showcase now, which we call advanced technique. Yes, in fact, in one of the examples that I'm going to mention later on, we still make use of gradient-based. Especially, we can make use of them in evaluation, in assessment. Yes, that's okay. Let's have the gradient-based. Let's have the search method. Let's see how our intelligent search, our intelligent optimization fare. So some new advanced optimization methods have been proposed that help to handle this complex problem. And in the available classification, we have put them, we have recognized them as intelligent optimization or intelligent search. Thank you. Now go ahead. Now, one of the advantages of this algorithm, because in any science discipline or engineering, we keep on, we are not relenting at all. The upsurge of research is even here as well, and that is exactly where I put the big data there. It brings about the upsurge of research, and the lecture is meant to invoke discussion, more research in that area. So one of the advantages of this algorithm is ability to find out information without gradient information. Furthermore, because they are less likely to be trapped in local optima. And then next, we are going to talk about the optimal criteria, where the way we have it, our optimality criteria, we can demonstrate it before a treatise on the intelligent organization. That we have said, we have tried to come up with all the terminology at that time. Our constraint set still remain my omega, and I'm telling you that, okay, my minimizer is lying here, either in the interior or on the boundary. So we have to derive condition for a point to be a local minimizer, which are summarized in the following theorems. Well, it's just to let us have. So now the first theorem here, one, I call it first order necessary condition, where the conventional one is grad f of s must be equal to 0. But this condition is meant for when you have your solution in the boundary. So when you have your solution in the boundary, you need the notion of derivative, what we call the feasible direction. So that is why this theorem is actually given out. Therefore, the second order necessary condition now, because these are just the first phase you have to meet before you can say this is a local minimizer. Sufficiency is coming up to tell you that, okay, yeah, I can say categorically that this actually identify and classify my X star, which is the solution, and that is the variables that I'm looking for. Where my F in this case is the Asian of F, where that is not other string to all of us, the conderivatives of n value function there. Next slide. Now, the second order sufficient condition, yeah, is for the interior case, and that is just for the interior point. If the set contains some neighborhood of S, and then we have all points within some neighborhood of S that are also in that my set. So you have the condition 1 there, grad of f of s star equals to 0, and your Asian matrix at that point x star must be positive. There and then we said our S star is a strict local minimizer of f. Now, here come the intelligent optimization techniques. It's a general term for a class of algorithm. And what it means is that human beings are also inspired by the collective behavior of various organisms in nature. And then we are able to find better, optimal strategies by imitating those intelligent behavior. You can find in birds. Yeah, I saw the demonstration of our mother in operation research, Professor Christian Deep yesterday, trying to allow us to see the flock of those birds, that those birds, there is an interaction. So the interaction will enable them to move in different directions, but when they are able to communicate and get the interaction right, they all move in the same direction. I stated earlier that the intelligent interaction are proposed due to those drawbacks. And what are those drawbacks? No guarantee of global optima can be attracted to solution, as well as highly constrained problem. This highly constrained problem tend to be cumbersome and at times uneasy to solve. So among other intelligent organization algorithms we tend to look at are the first here, our generic algorithm, where my lecture seems to have preempted a lot of our speakers, and I give credence to our mama yesterday, our mother, Professor Hugh, and our Professor Hussein from Egypt. So they are dwell more on the nature-inspired technique, which I'm also going to just summarize here. So the genetic algorithm is the first developed by Charles Robert Darwin, and is inspired by those basic elements and facts of the theory of evolution. It is based on genetic concepts and explained by the theory of evolution, the selection, the mutation, and the crossover processes to solve real-life based problem. I think we have seen a very good example and demonstration yesterday. Now, next slide. The genetic algorithm are typically implemented as a computer simulation in which a population of abstract solution called the chromosome and a candidate solution called the individual transplantation evolved toward better solution. Widely accepted because of its simplicity, ease of operation, minimal requirements, and a global perspective. It is a credited intelligence organization and has been reported successful in Suku et al. 8 and Kumar 1. All my references or citations are accessible. Yes, they are accessible. Reported successful in solving a wide variety of search and optimization problems described in sciences, engineering, and commerce. Next slide. The next one is simulation analysis. The name and motivation is coming from annealing process in metallurgy, a technique involving the heating and control cooling of a material so that you can increase the size of its crystal, and then the defect is going to be optimized or reduced. In this technique, each point of the search space is compared to the state of some physical system, and the function minimized is interpreted here as the internal energy of the system. That's it. Therefore, what we are working towards is what? We want to work towards a state with the minimum possible energy, according to the reference 1 and 2. And the next one is my PSO. It's also one of the swarm intelligence. Yeah, as you can see yesterday demonstrated, it is one of the technique categorized as a population-based stochastic algorithm. Also model on the social behaviors observed in flocking birds, in the swarming fishes, and so on and so forth. And what it does is that you have your particle attracted towards the global base, while it has tendency to move randomly. So when it moves randomly, when a particle finds a location better than the previous one, what it does, it just updates as the new solution. However, yeah, one of the, yeah, I need to, next slide, please. Next slide. Yeah, thank you very much. Yeah, the bulk of my work is centered on these phrase, on this word, big data. Yeah, because it gives an opportunity for what we are doing. It also adds credence to the importance of the optimization, intelligent optimization. Yeah, the big data issue or error is actually allowing the whole world to know the importance of algorithm. So according to Joshua Young, there are two popular definitions. The definition given by Gartner there says big data requires a new processing mode in order to have stronger decision making. You need to have an insight and process optimization capabilities to adapt. Yeah, there are some features there. You have to adapt to the massive high growth rate and diversification of information assets. And that is the first definition there. And the second definition is actually taking us to the V that characterize big data one by one. Next slide, please. What are those V? One, we have said massive. This concept expresses a very important meaning. Big data has now become an information asset. It has come with a lot of opportunities as well as a lot of challenges. No doubt, we need new processing models to process this information asset. Because the original processing mode cannot deal with this data, with these 5 Vs. It was initially 4 Vs. The IBM added the other one, the last one, which seems to be closer to the fourth one. And the concept is now forming the characteristic of big data. Let's take a look at these 5 V one by one. When we talk about the volume here, we are talking about a situation, the kind of data whose size is beyond the processing ability of typical database or computer. It's so massive, and you know the way we generate those data, our videos, our social media, our internet, and so on and so forth. We are, in fact, on the go, we generate so massive, and there is no doubt there is a lot of bad data inside the big data. There is a lot. So it's now meant for us now to see how we can bring out valuable data in the bad data, or fish out, separate the bad data in the big data. So the content needs to be met. And again, the velocity, fast data flow, real-time traffic information is necessary. And in this case, rapid change of data content. So the content of the big data keep increasing over time. So there is need for us to target, the target of big data also need to change with that time. Yes, it has to change with that time. And then the variety, which seems to be the most compelling feature there or characteristic, is talking about what? Diverse data types. Yeah, we have different sources of data and different types. So we have to crack multiple objective problems with less restriction on objective function. So we are talking about the data complexity there, the missing value, the noise. How can we separate? Then the imbalance and the data set shift as well. So then the value of the insight and the benefit. We are talking about how we can have the benefit of all those values by the time we are able to process, able to analyze. Yeah. However, it does not still rule out the earlier conventional method, our statistical analysis, correlation analysis, and so on and so forth. They are still there. Then the veracity, value of data mined is always very, very high. Uncertainty is there. Inconsistency, incompleteness, model approximation, and so on and so forth. These are the features that doesn't give room. I mean, that actually give opportunity for the importance of a new strategy, a new technique. We wrap up as our intelligent optimization. Now, these 5 big characteristics, next slide, Next slide. Next slide. Okay, this 5 P characteristic of big data tell us that today's big data refers not only to data, but data plus a series of processing techniques. We need to mine part of data that will surely be suitable, valuable to our work. And again, we are interested in doing that within a reasonably good, getting a reasonably good performance. Yeah, while we are working towards having a limited time, we are optimizing already. We want to have very short time. However, we still want to make valuable decisions, reasonable good performance. The whole process is what we have here as our big data. Now that takes us to our application. Yeah. Now the application extends to many disciplines, numerous to mention: medicine, engineering, finance, economies, transportation, education, manufacturing, marketing, and many others. So in the references here, Kumar, reference number 2, OSINUGA et al. Yeah, I have also worked in that line using the particle swap optimization. Nabina and Stevano, yeah, has also given us information. Lin et al., Kupi, Aleppo, and Novakshi, they are also, and likewise assist. So we are going to present 4 different cases, real life cases, to justify the importance and to also see why the optimization, intelligent optimization is necessary. The first one is here from industrial application. According to Kumar 2011, disassembly sequence planning. It goes thus: disassembly is considered a key to retrieve the desired part. Performing disassembly in an optimized function is a decision of, is a welcome decision, and that has to be the properties of the product and the limitations set by the disassembly system. So in this particular work, which our audience can check, like I said, all the citation, all the reference articles are accessible. They are accessible online. Optimal disassembly sequence is reported to be attained using intelligent optimization, such as genetic algorithm assimilation and LA. Yeah, Kumar 2011 actually make use of those 2 intelligent optimization techniques, and they are reported successful in solving a wide variety of such problems described in sciences and engineering and commerce. We can move on to case 2. Yeah, the case 2 is taking us to an example, a very good example in education, where we intend to improve the effectiveness, the availability, for the intelligence of smart education. According to Lin et al. There, they propose an optimization framework-based approach, yeah, for course recommendation system. And so that is, you can check that one up. Now the case 3 is actually my own area, facility location problem. Yeah, for many people who is interested, who have been working in this area, facility location is a typical real life cases where you intend to optimize the placement of facilities such that demand can be met at the lowest cost and or shortest distance. Yeah, by my one of my earlier speaker, I mentioned shortest distance when we are talking about process optimization, because so far, before my own lecture, I also participated fully in the lectures of all former speakers, and I really enjoy it. I give them credence. Now, you need distance function here. It could be Euclidean. Several distance functions have been defined. Somebody has mentioned adding distance this morning. You have a lot of them. So in 7, what are we after? We use the modified PSO to solve single facility location problem. But here and then, we did not rule out gradient based. When speed algorithm is a gradient based optimization technique. Yes, you need brilliant information here. That's why I said we cannot rule it out. And again, by virtue that all the optimization optimization techniques that are being proposed, even tomorrow, the basis is still from the network or direct search method. So it is shown that the PSO solve effectively and efficiently the optimization problem. This is single facility. We have multi-facility as well. And I'm sure PSO can still perform wonder there. Followed by the conventional PSO, while the Westfield algorithm perform worst here. Next slide. Then the case 4 is immersing. I have the classification algorithm, and I have to refer to the work of Axis et al. 2014. Yeah, where they propose a new method. This method actually combines, we call it hybrid in optimization technique. We will hybridize some technique, 2 or 3, to be able to exhibit the advantages of the component techniques. So this is an hybridized algorithm that a new method is proposed in this work that combine genetic algorithm and support machine classifier in order to reduce dimensionality. Yes, that is one of the key things in the big data. Big data has come with several diversity that you have no option. There should be some techniques that can handle those dimensionality and optimize classification process. And the experimental results show in this work that the potential benefit of the algorithm to specialists, clinical interpretation. In clinical interpretation of mammogram, yeah, breast cancer has been a problem all over the world, but I'm sure if this kind of intelligent technique can be put to use, I'm sure they have reported, and that is the essence of research. That is the essence of research. So we can implement and see how we can as well optimize, the life of our people. So, and then with that, we have the conclusion. Next slide. Next slide. Okay, in conclusion, this work has complemented others in the aspects of application of intelligent organization to real-life-based complex problems, and especially the feature in the area of big data. So I have to acknowledge the International Mathematical Union, the Simon Foundation, and one of my collaborators for over a decade of research and academic cooperation. So all the references are listed: Kumar 2014, Kumar 2011. Next slide, please. And I have a chunk. It is only one that's just a book and it's just a lecture. Bamibola OM. All other ones, they are all accessible, including my own work. They are all accessible. So for further discussion, for further research, any of the literature can as well be looked for further study. Last slide. Thank you. Last slide. And then with that, I want to say a big thank you to the organizer for this wonderful opportunity for me to even stage a comeback. And I want to apologize to the whole house. So please give me I'll be more proactive in future. Thank you very much. Thank you.
Thank you. Thank you, sir, for your words of wisdom. We are benefited a lot with your motivational and information-oriented lecture. Thank you so much. Participants can fill up the feedback form, whose link is given in the chat box, YouTube, and WhatsApp group. Now, participants can ask their queries. From Professor OSINUGA.
Host can unmute everybody.
Also, I request the host to unmute everyone for some time so that they can ask their queries. Participants can ask their queries in the chat box also.
We can share the slide with them later on, if possible, the organizer.
Okay, thank you everyone. Also, I thank Professor I.A. OSINUGA for delivering his lecture. Sir, Punjabi University Patiala feels proud to have you as a resource person today.
Thank you very much.
Thank you, sir. Now I request to the host of this webinar to award the certificate of appreciation to Professor I.A. OSINUGA. Thank you, Professor I.A. OSINUGA, for being with us and spare time from your busy schedule.
Thank you very much.
Thank you, sir. Now I request Professor Satyavir Singh, who is the convener of this webinar, to say some words of thanks to Professor I.A. OSINUGA.
Thank you, Professor OSINUGA. Thank you very much. You was very energetic since morning, but internet connectivity created a little problem in between.
Yeah, we have
on behalf of our entire team at Punjab University Patiala, we would like to express our gratitude for your talk on various aspects of optimization, intelligent research, and artificial intelligence. You have very nicely connected optimization with big data and artificial intelligence. Your talk was not only extremely informative, but also kept everyone entertained in their seats. The size of participation on WebEx as well as YouTube during your talk is a testimony to how thrilled everyone was to listen you speak. Thank you once again, Professor OSINUGA. We will keep in touch for further course of action and other activities, upcoming activities in Punjab University Patiala or MathTech Thinking Foundation. Thank you so much.
My pleasure, sir. You're welcome.
Thank you so much, sir. With this lecture, we call it a very successful day. Thank you all. Thank you very much.